Hi, this video is to quickly explain the fundamentals of recursion. Recursion is different to all the functions that we've done up to now, in that with all the functions we've done up to now, these functions were called from main. So from within main we called functions, the functions performed their duties, and then it returned. These functions could also have been called from other functions, so we made functions that called other functions. But with recursion it's different in that these functions call themselves, so it could get quite confusing, and I'm going to try to take you through it step by step using an example. So on the example that you've got on the screen there, it's the definition of factorial. If you look at the definition of factorial, it contains the use of factorial inside the definition of factorial. So the factorial of n is equal to either 1 or it's equal to n times the factorial of n minus 1. So inside the definition of factorial we use factorial, so it's a self-referencing definition. So to implement this, we're just going to quickly look at the C code. I'll show you what the C code looks like. It's something like this. We have a main, and inside main we have x, integer x is equal to factorial of 3, and then we have a function factorial, and this function implements exactly that. It says if n is equal to 1, the result is 1, else the result is equal to n multiplied by factorial n minus 1. So it's exactly the implementation that we have here. It's just written down in C. And what I have on the screen now is just exactly that same thing, but it's just written down by hand because I want to make some drawing. So if you look at this, as I said, we have int main, a variable x, and here we say x is equal to that factorial of 3. Lines of code, return with a 0. And over here we have that function, int factorial, by the way it has a prototype up here that I've not shown, int factorial, which is receiving an integer, so it's returning an integer, it's receiving an integer, and it's called n. And then we have a check inside. If n is 1, return 1, else return n multiplied by factorial n minus 1. Good. So let's see what happens inside the computer when this runs. Starts from the top, creates memory for a variable called x, and then it goes through the lines of code, goes through, and then we make x equal to a function call with an argument of 3. So what happens with the arguments in a function is this value of 3 is taken, it's copied, and it's pasted inside this argument here. So from this point forward, when this function is called, the value of n is equal to 3. So let's go into the function. So I'm just going to write down n is equal to 3 here. So the function goes in, is 3 equal to 1? The result is false, so it jumps to the else part of the if. Else returns n times factorial of n minus 1. So 3 times factorial of 3 minus 1. So now the question is, what on earth going on here? And what I want you to do is to just imagine for a second the function factorial is called. So let's pretend there's another function called factorial, and this function looks exactly identical to the previous factorial function. So it also gets an integer in, and it also has exactly the same check. If n is equal to 1, then return 1, else return n multiplied by factorial of n minus 1. So what you can see is this is an exact replica of the function that we had here. It's exactly the same. The only thing is, it's as if a new instance of it is called when we call the function. So let's pretend it's another function, factorial, and that is called. So what happens now is the value of n is equal to 3, so n minus 1 is equal to 2. So this value 2 is sent, it's copied and pasted. We call that operation called passing. We're passing the value 2 to this function. So now this n is equal to 2 here. So in memory, there's an n for this function, and there's an n for that function, both local to the function. So this could be something like factorial underscore n first instance and factorial underscore n second instance if you want. But basically there's two separate places in memory called n, and this one is equal to 3, this one is equal to 2. So now it enters here. The program cursor is the thing that tells you where you're at the program. So initially it went here, 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 from the top to the bottom, sequential coding, jump to here, and then the program cursor says, hey, we have a function, so we rather jump into the function here, starts to runs its way through, and as you can see, it checked this, it was false, so it got here, so the program cursor got to this point where there was a function call, so the program cursor jumped into this function here. So it's going on here. So anyway, n is equal to 2. So the check then is, what is this? Is 2 equal to 1? The result is false, so it returns with a 0. So it does the false part of the if, which means it's returning 2 times the factorial of n minus 1. So let's just pretend this factorial call is spawning another instance of this factorial function. Let's just pretend there's another one. In fact, it's all the same function definition, but every time you call it, it's as if it's copying a new instance of that function. So int n and begin and end if. Just gonna pause the video while I quickly draw this out. So what you can see is this new function is now spawned because it's called from here. But in this instance, n was equal to 2, so this here, n minus 1, results in a 1. So this 1 is taken, copied, and pasted into yet another space in memory, also called n, and in this case, n is going to be equal to 1. So now the if goes, is 1 equal to 1? The result is yes, so it returns with a 1. Sorry, this logic check results in a 1, which means true. So if true, return 1. So this part is executed, this part is ignored, so it returns with the 1. And this is where it gets interesting. So what happens now is, this whole function, which was called from this point here, returns with a 1. So the 1 is taken. Remember, its type is integer. So that 1 is taken, it's almost as if it's going through that route there. And then this whole function call, that whole thing there, is replaced by a 1. So 1. So the n here we said was equal to 2. 2 times 1 is equal to 2, is equal to 2. So this returns with a 2. So through this integer type, if you want, it returns a 2. So where was this thing called from? It was called from here. So that result 2 is popped back, and this whole thing here is replaced with a 2. Remember, n was equal to 3 here, so 3 multiplied by 2 results in 6. So this function returns with 3 multiplied by 2, its result is 6. It's a type integer, it's sent back, and this whole function call is essentially replaced by a 6. So x's value becomes equal to 6. Right, if this was factorial of 4, it would have just spawned or called this function for 4, then for 3, then for 2, and then for 1. So as many times as it's required to do it, it will create instances of this function to perform the functions that you want. So let's just quickly evaluate the C code for that. This is the C code, and what you can see is, I'm just going to add a printf here. What you can see is exactly the same code. I've not immediately returned the result, I've just made a variable int called res for result. I've put that is equal to either 1 or it's equal to n times factorial of n minus 1. And all I'm doing is I'm printing out the factorial of is equal to and the two are n and res. So if I run this, you can see that it says the factorial of 1 is returning 1, the factorial of 2 is returning 2, the factorial of 3 is returning 3, and the result is 6. But that's not quite that insightful. What really helps you understand this better is if I add this function is called, I'm just going to print out the function is called with n is equal to, new line, and we're just printing out n now just to see what on earth's going on. So what you can see is happening is, first of all, the function is called with 3, but in order to calculate it for 3, it needs to be calculated for 2, because, just go back at the code here, in order for it to calculate the factorial of 3, it needs to first calculate the factorial of 2. So the function opens again, and it prints out n is equal to 2 now. That's why we have n is equal to 2. Then, in order to calculate the factorial of 2, it has to call the function factorial of 1. So it calls the factorial of 1. Then, this function is the one that returns with a 1. Remember, it returns with a 1. So this printout that I added in the code, in this case I printed it out here, it's returning with a 1. That's the first thing that returns. Then, on the next instance, this function here returns with a 2. So you can see what's happening here. Factorial of 2 is returning 2. Okay, so when it's calculated that, jumps back and finally calculates the factorial for 3. Factorial of 3 is equal to 6. And then inside main, the result is equal to 6. Now when we get to the factorial of that, so that's a fairly simple factorial, or rather a fairly simple recursion example. If you get down to the factorial of the, or rather the definition of the Fibonacci series, that's a bit more complicated. So I'll quickly do an example for that as well. Okay, so as I said, Fibonacci is a bit more complicated. I've quickly written down the Fibonacci implementation here, and what you can see, let's just go back to the definition quickly. The Fibonacci says Fibonacci of n is equal to one of three things. It's either equal to 0 or 1, or it's equal to the Fibonacci of n minus 1. Sorry, that's Fibonacci actually. Fibonacci of n minus 1 plus the Fibonacci of n minus 2, and it all depends on what your input n is equal to. So if you jump to the code, you can see I've got done the implementation here. Int x is equal to, at this point I'm setting it equal to the Fibonacci of 3. So the Fibonacci of 3 will then obviously call the Fibonacci function, and the program cursor will go from the top to the top up to this point and then say x must be equal to something. What is that something? Well, it's the Fibonacci function. So spawn, if you want, create an instance of that function, call an instance of the function, perform that function for 3. So what happens is that 3, that value is taken and it's copied and pasted into this n. So at this point then, n is equal to 3. So what happens to the logic? If n is equal to 0, it should return 0. If n is equal to 1, it should return 1. But neither of those are true. N is equal to 3. So it goes into the else, and the else says return Fibonacci of 2 plus Fibonacci of 1. Okay, so now that's a bit different to the example we had earlier, because what now has to happen is this needs to spawn one instance of the Fibonacci function. This needs to spawn another instance of the Fibonacci function. So while I do that, I'll just pause the video again. Right, so the top Fibonacci receives the value 2. So 2 is passed, and then this copied and pasted into that n. N is equal to 2. And Fibonacci is also called with the value of 1. So then 1 is taken, and then inside this function, n is going to be equal to 1. Right, so let's look at the first function first. The first one that happens is obviously, if you want, it's this one. Because it's plus, you could have also said, listen, it's called once, and then it's called again. I'm just doing it as two instances to illustrate the point. But first, the Fibonacci here is calculated. So n is equal to 2, neither of those will be true, so this will return with the Fibonacci of, remember n is equal to 2, so Fibonacci of 1, Fibonacci of 0, and again, a function is spawned for each one of these. So here will be another Fibonacci, here will be yet another Fibonacci, here, and then each one of them will, in their own, look like this here. Let's just, I'm not going to write it out again, but what you can see is, if you just take this and put it here, you can see that when Fibonacci of 1 is called, this will return with a 1. When the Fibonacci of 0 is called, this will return with a 0. So I'm just asking you to apply this logic here and here. So that will return with a 1. This will return with a 0. So this will come back, and this whole thing here will be replaced with a 1. This will come back, and that whole thing here will be replaced with a 0. So 1 plus 0 is equal to 1. So the whole function returns with 1. So the Fibonacci function comes back, it returns with 1. Then it adds to this Fibonacci. Now this Fibonacci, we said, is spawning this function here, and this function, the Fibonacci of 1, will obviously return with, this case here, with just return with n, which is equal to 1, so it will return with a 1. So this whole thing here is replaced by a 1, so we have 1 plus 1 gives you just a 2. Right, so if you now consider the example that we just did there, that Fibonacci of 3, as you can see here, the whole thing returns with 1 plus 1 is 2. So that here, this whole final function here, returns a 2, so x will be equal to 2. I'm just going to show you the code for that quickly. If I implemented the same thing here, so Fibonacci, there you can see Fibonacci function, and the Fibonacci function just says if n is equal to 0 or 1, it returns with n, else it returns with Fibonacci of n minus 1 plus Fibonacci of n minus 2, and it returns with that result. If I then call Fibonacci of 3, and I put that into x, I print out x, and I then run this, you can see the result there. The result is 2. But the confusing part is what happens inside here, so I just want to take you through that. Inside Fibonacci, we have print out Fibonacci is called with this. Then at the end, I just say Fibonacci of is returning with this. So I want to talk you through that quickly. So first of all, Fibonacci of 3 is called, and if you look at this, Fibonacci of 3 calls the Fibonacci function of 3. So that's why we have function is called with n is equal to 3. So at this point, more or less, we do the printf here. So it says, hey, I've received a 3, I need to calculate it. Then what happens is the function is called in itself, and it is calling it with the value of 2. So the first thing that happens inside there is we're printing out it's called with the value of 2. Before this function here returns, before it reaches the return, right, we print out what we've received, and then the if here we said was false, so it jumps in here. Before it can return, it needs to calculate first of all the Fibonacci. So it calls this function, and the first thing this does is print. So before this one can return, it goes into another instance of the function and it prints out I've been called. In this case, I've been called with 2. So the Fibonacci, you can see the Fibonacci of 2 when that's called, it enters this base. Before this function can return, it calls another instance of Fibonacci with 1. And that's why we expect it to print out again, I've been called by 1. Right? And that's what you're seeing here. Fibonacci is called with 3, Fibonacci is called with 2, Fibonacci is called with 1, right? So this calling of the function with the value of 3 has spawned the calling of the function with the value of 2 here. That calling of the function with the value of 2 has spawned a calling of the function with the value of 1. Alright. Then, when this calls it with a 1, it returns with a 1. So inside this function here, it's going to print out, I'm returning with a 1. So that's what you have here. I'm returning with a 1. Then, that 1 goes here. It needs to add it to the Fibonacci of 0. So that spawns this function here. So that's why it then says Fibonacci is called with n is equal to 0, right? N is equal to 0 does return without having to call Fibonacci again. So it says I'm returning with 0. So I'm returning with 0. So at that point, we're here. We're adding that 1 to that 0. It gives us a result of 1. So inside this function, it's printing out, I'm returning with the value of 1. And that's what you have here. Fibonacci of 2 is returning with 1. Good stuff. So when that returns, it jumps back and it populates this. Next thing it has to do, it has to add Fibonacci of 1. So that spawns this function here. So this function here, first of all, says I've been called with n is equal to 1. Okay, so inside here, Fibonacci n is equal to 1. So this true check, or this if check, checks out true. It returns with 1, so it prints out I'm returning the Fibonacci of 1 is equal to 1. Fibonacci of 1 is equal to 1. So the function pops out, it returns it into here, calculates the lot here, and then it prints out the result of Fibonacci of 3 is equal to 1 plus 1, which is 2. So the Fibonacci of 3 is equal to 2, and then it prints out inside main, it prints out the result is 2. So just to be clear about that, inside this function, I've not just returned, as I have done on the paper, I've actually just added a step here to print out the result before I return it. And that's why we had those returns. And this is the main part. This is just printed out the Fibonacci is 2. So hopefully that didn't confuse you too much, rather helped you out. But you can see here, this is, if you want to follow that logic, this is exactly the same what happens there.